finish up with our quadratics, there's a very helpful formula. What this formula says is, anytime I have a quadratic, ax squared plus bx plus c equal to 0. What happens is, if I want to solve for x, x is going to equal, now the formula looks kind of intense, and if you look in the book, it tells you where this formula comes from. It comes from completing the square, and there's a whole method we have to go through, but don't worry about that right now, because all we've got to do is have this formula written down, and all this is just plug and chug. All I've got to do is substitute my a, b, and c in here, go through the operations, and I'm done. Now, here's where it's extremely useful. Here's a quadratic equation, x squared plus 6x plus 4 equal to 0. Ultimately, yeah, I just want to solve. Problem is, like last time, I can't just subtract and divide. I've got an x and an x squared. Problem is, I can't factor. Quadratic formula is what you do when it doesn't factor. Now, this actually is easier, and this actually will work even if it does factor. In fact, some students will still use it. Factoring can be quick, but we'll show that if there's a leading coefficient, sometimes this can even be better. All I need to do is identify what are A, what are B, and what are C. A, my leading coefficient, is 1. B is 6. C is 4. All I've got to do is come over here, plug and chug. Minus B was 6. Plus minus square root of B was 6 squared. Minus 4 times A was 1. C was 4. Divided by 2 times A was 1. Plug and chug. All we got to do is just go through our operations. What I do first is look at, and this was called, if you want to know its name, it's called the discriminant. Doesn't matter what it's called. What I do is pause and play. 6 squared. All right, great, 36. Minus 4 times 1 is 4, times 4 is 16. 36 minus 16, 20. Now that I have a radical, here's where we learned our steps. I got to break it down if possible. 4 and 5, right? Not 2 and 20 because neither of them are squares. I put the 4 in front because it's the square. It ends up being, square root of 4 is 2. It becomes my coefficient. Why I put it in the front. Why I broke it down. Well, now, just put it right back in. That's why I call it like a pause play. I end up with negative 6 plus minus 2 root 5 divided by 2 times 1 is 2. But just like we saw before, divide each of those by 2, and what I end up with is negative 3 plus minus 2 root 5, meaning my two answers, I'm sorry, negative 6 divided by 2 is minus 3. 2 divided by 2 was 1, but I wouldn't want to put that 1. 1 times anything is just itself. I would just leave it. My answers, negative 3 plus root 5, negative 3 minus root 5. Which, remember, that is a number. Square root of 5 is about, 2.2, 2.3, somewhere in that range. Negative 3 plus 2.2 would be negative 0.8. Ballpark. That means negative 0.8. If I square it, take it times 6, add it to 4, gives me 0. Negative 3 minus 2.2 gives me negative, in the neighborhood of 5.2, somewhere in there. That's the number that if I square, take it times 6, add 4, also gives me 0. I would want to leave it as the exact value. I just wanted to point out that those are actually numerical values, numbers that I can plug in and will work for x.